Kia ora, Year 12. I'm going to go through two questions from exercise 8A that Jameson asked me about. So big thank you to him for emailing me in. It's really good when I'm not seeing you all the time to get feedback on where you're stuck. And I think the main problem with this first question, which is 8A question 1 part 5, is that even if you do all the integration right, you have to do some algebra at the end to get your answer to match the factorized answer in the back of the textbook. And every year I forget to say that when I teach this topic, and then we get to 8A and I remember. And then the second one is a nice one because this is from question 2 part 3. I'm going to show you two different ways that you can do substitution here. Okay, so let's start off over here. First, let's look at this one. And let's just have a look at why we need substitution in this question, right? So it's not just a silly early example where we could really do it without. If we write that in fractional powers, and we just take a look, and we think about this bit here, and we say, well, what if I put it up by a power and it was 3 over 2, right? So cover up this bit with your finger, and think about the derivative of the inside function. Well, the derivative here is just a constant, it's 2, and that doesn't fit with, oh, I don't know what happened there. It doesn't fit with having an x here. So this is a great candidate for doing substitution on. The question is, what substitution are we going to do? Now, I can't remember if the book told you which one to use or not, but the obvious one to use in here is to let u equal 2x plus 1. So we'll start off like that. So let u equal 2x plus 1. We can go ahead straight away and differentiate it, and we get du by dx equals 2. Remember, we're trying to sub out everything that's got x to get u. So we get du equals 2 dx, not quite how we want it. So now we have a half du is equal to dx, and we can put a little box around that and a little box around that. The last thing we need to do is to figure out what x is. So u minus 1 is equal to 2x. X is equal to u minus 1 over 2. We don't have any limits. So we're good to go now. We can start substituting. So let's do that down here. So we've got to clean this up a wee bit. You can see that we've got 1/4 times the integral of u to the power of 3 over 2 minus u to the 1/2 du. So a nice easy integration problem now. It's going to give me 1/4 times 2/5 u to the 5 over 2 minus 2/3 u to the 3 over 2 plus c. So now we have to sub everything back in terms of x. So we get 1/10 of x, 2x plus 1, not 5, to the power of 5 over 2, minus 1/6 of 2x plus 1 to the power of 3 over 2 plus c. Now, I would give that a big tick at this point, but you're probably going, well, how the heck do they get what they get at the back of the book? And what it's all about is taking out the highest common factor here. So it's just like the factorising you did back in year 9, only a little bit harder. So we've got 2x plus 1 to the power of 3 over 2, times 1/10 times the leftover here. So it's 1/10 of 2x plus 1 minus 1/6 plus c. Cleaning that up takes a little bit. What we're looking to get out is just a linear factor and a constant. So here we've got 1/5 x plus 1/10 minus 1/6 plus c, which gives me this, and I get 1/5 x plus, now 1/10 minus 1/6 is over 30, it's 3 minus 5, so it's negative 2 over 30 plus c, and this is 1/15. Now that looks really messy. We're going to clean that up some more. We're going to take out a constant here of 1/15. So even though I really like algebra, if I was sitting in an exam and I hadn't been told to get it into this form, I really wouldn't bother. But it does look nice. So there you go. So it's 1/15 times that, times this, plus c. And that's how we get exactly what's sitting in the answers in the back of the book. Let's go back now and look at the second question we're going to do. and that's this one here, which is a definite integral, so we're going to have to change the limits. Now, I'm not doing too bad on time, so I'm going to do the second question using two different substitutions to give you a feel for what a difference that can make when you're doing the working on a question. So we've got the integral between 5 and 1 of x root x minus 1 dx. So the first time through, I'm going to do it using this substitution. So du by dx is equal to 1. And that gives me du equals dx, so that's nice, and lastly we have a very easy changing the subject, x is equal to u plus 1. And the last thing that I've got to do is do my limits. So my x limits are 5 and 1, and my u limits are 4 and 0. So what can we do with this? Well, we get this to start with, switches over to become this. And remember that we looked at the end of today's lesson just with that badly drawn graph of how we're shifting everything along. So we've got u plus 1 times u to the power of a half du. Now these are actually easier because we're just going to substitute in the values, so we don't have to put it all back in terms of x, so it's much cleaner. So 2/5 u to the 5 over 2 plus 2/3 u to the 3 over 2 between 4 and 0, which gives me 2/5 of, well, we read this as the square root of 4 to the power of 5, and we read this as the square root of 4 to the power of 3, and the second part with 0 has 0 for both of those bits of the expression, so that gives me 64 over 5 plus 16 over 3, and we're told to do it to 3 significant figures, so that gives me 18.1 to 3SF. Okay, now the other way that I could do that is using, instead of doing that substitution, let's look at the other substitution that I could do. And this is like the first one that I did in class, which is that I could make u equal the square root of that thing there. So let's just look at what happens if I do it that way. Just finding my piece of paper, here we go. I just want to show you that it comes out exactly the same, even though it looks very, very different. So we're starting with this. The pen's going weird here, between 5 and 1. But this time let's say let u equal the square root of x minus 1, because it looks like it might be a good thing to do, right? Because it knocks all of that square root out, and we don't like square roots. So u squared is equal to x minus 1. U squared plus 1 is equal to x. So that's good. Now we can differentiate, and we'll differentiate dx with respect to u, and we get that. So dx is equal to 2u du. The last thing, so that's good, and that one's good, and now we've got to do our limits. Oops, so that's my x limit, that's my u limit. So u is equal to root x minus 1. So here we have the square root of 4, so the u limits are 2 and 0. So this whole integral is going to come out exactly the same, but it looks really different on the way through. So it doesn't go from 4 to 0, it goes from 2 to 0. The x becomes this thing here. And you can see that we've got no square roots left in here, so that's nice. So we've got 2u to the power of 4 plus 2u squared du. That gives me 2/5 u to the power of 5 plus 2/3 u cubed. And now you can see that the two things line up. And if we shove all the values in again, not surprisingly, we are going to get 18.1 to 3SF. So there you go, 2 questions done. Let me know if you want more, especially towards the end of the exercises. And remember, the work solutions for the other exercises in Chapter 8 are mostly up on Google Classroom in the usual place. So yell out if you can't find them or you're stuck.